So now we are going to see the linked list in data structure. So in this PPT, we are going to see about the linked list and types of linked list and what are all the operations may be done in the linked list. What is linked list in a data structure? A linked list is a linear data structure in which the elements are not stored in the continuous memory locations. The elements in a linked list are linked using the pointer. The linked list must contain the node. The node is to be partitioned into the data node and the next node. The data node is contain the element of that node. The next node is contain the address of the next node. Working of the linked list. The linked list consists of the node. So already we seen the node is to be the partition into the data field and the reference field. So the data field is contained the element. The link partition is to be contained the address of the next node. The array in a data structure. The array is a collection of the element in the same data type. It is stored in a memory in a continuous memory locations. It is represented using the index value. If we need to fetch any element in any array element, we can using the index value of the array, we can easily fetch the array. When compared to array with the linked list, the advantages of the linked list is the linked list consists of the dynamic size. Because the array is not the dynamic size. It provides a static memory location. Once you fix the array size, you couldn't change the array size during the runtime. And also the linked list is the ease of the insertion and the deletion. In an array, we just insert the element, we just given the element into the array. Disadvantages of the linked list. The random message is not allowed in the list. We have to access the element sequentially starting from the first node. Yes, of course, if you are needed to fetch any element in the list, we need to travel from the first node, that means the head node to the end node until you reaching your searching node. But in case of array, using the index value, you can easily access the element stored in the array. Extra memory space for the pointer is required with each element of the list. When compared to array, the array is having only the element only stored on the index value. But in the linked list, it occupies the memory location for data and as well as the pointer variable. Not cache friendly, since array element are continuous location, there is locality of reference which is not there in case of the linked list. In the linked list, the node is to be stored in different locations of your memory. Each node, for example, if the first node is to be a, the second node is to be a B, the third node is to be a C, means the A node having the address of the B node. So the A is using the next pointer value, the B address, it fetched the B, and as well as the B is having the C node address and the B linked with the C. So based on the pointer variable only, they are linked together. But in the array, it will be stored in the continuous memory locations. The operations in a linked list. Traversing a linked list, append a new node into the list, prepend a new node into the list, inserting a new node of a specific position of a list, deleting the node from a list, and updating a node in the list. Types of linked list. The linked list is to be classified into singly linked list, circularly linked list, doubly linked list. Singly linked list. The singly linked list means the node is consist of the data node and the next pointer, and each node having the connections between the next node in the singly manner. And the circularly linked list, the node connected with a singly list manner, but it doesn't have any end node because the end node points to the head node address. In the doubly linked list, each node having the two pointers and the data element. In the previous and the next pointer is using the pointer variable, the data is having the data element. The previous is having the previous node address, the next is having the next node address. Always the first node is having the previous as the null, and as well as the last node next pointer is having the null value. In this, each node connected with the next node based on their previous and next pointer. In this, the next pointer shown to the next node, and as well as the second node having the previous address, so it connected with the first node. Similarly, the connection is to be linked. The link is to be linked based on the pointer variable. Now we are going to see about elaborate in a singly linked list. A singly linked list is a linear data structure. The nodes are connected in a singly linked list. In the singly linked list, the node partition into the data and the next pointer. Now, in this program, how to create a singly linked list is to be explained. So, if we are going to create a singly linked list, first we need the int create, and then we need number of elements to be created. So, using getting the input, and for that node we need the element to be inserted. So, first the case we need to get the node, and then we need to get the element. So, in a memory, we need to allocate the memory size for the node. So, in this step, heads equal to struct node pointer malloc pointer size of struct node. The malloc method is to be used to allocate the memory for this node. So, in this step, the node is to be created. In the beginning, the node must be contained. The next node is to be a null because it is the single node. The single node didn't have any connection with the next node. So the first node created node is the head node, as well as the head node next pointer is point to the null. So that's why head next is equal to null is to be assigned, and then old is equal to head for loop. The purpose of the for loop is we need to create next node. So if we will give the maximum size of the list, on those size the node will be created using the malloc function, and as well as we need to give the connections to the each node. So in this, p is equal to next is equal to null. The head node is to be assigned for the p. The old node point to the p. The new node is to be created as the p node. The p node is the second node. Second node next pointer is null, and now the old node is head node. The first we will created the node. That head node is point to the head node next pointer is to be the p pointer. Okay, so the p is stored in the memory. P is the second node. The memory address of the p is to be the address of the first node next. So we will assign old is equal to next of old next is equal to old, and then it will be created until the maximum size is to be attained. And now we will using the traverse method. How many nodes are created is to be viewed using the traverse method. And now in using the singly linked list, how do we will traverse? So in the previous example we will see the traverse method. So traverse method is used to travel over the linked list. The traverse is to be done from the beginning node to another ending node. So first beginning node is to be the initial step. So I assign the p is equal to head node, and now this is the list. I need to print the element on that list. So I print this is the list. Why p not equal to null? Because if the pointer is to be the null, that means if you are created a single node means that single node next pointer may be the null means there is a node next node is to be available. So I am checking while the p not equal to null. P next pointer is not equal to null means the traverse is to be done on the next node. So print is to be used to fetch the element on that each list, and also printing that in the list. P is equal to p of next. Once the first list element is to be printed, and next the p is to be transferred into the next node. So the p node automatically switch over to the next node, the next memory location, and then the while loop is to be frequently checking whether the next node is contained the null or not. If the second node is also having the third node address means the while loop again process and the second node element is to be printed and as well as the P is point to the third node address. So P switch over to the third node. If the third node is the last node means the next pointer is the null pointer. So the while loop is to be completed and the traverse is to be printed that each element is to be located on that list. For this below program, if I will assign the P for first node A, the P is not equal to null because A is contained the 200, the address of the B node. So the B is printing the 200 as the first output and the next P is equal to P of next. In the first node, A node consists of the 200. Now I am doing P is equal to P next means P is points to the memory location of the B node. So now the B node 200 is to be the P address. Now the P checking whether the P next is the null or not. Yes, of course. P next is 300. It points to the next element. So now it print the numbers in the B. It print the B and then the P is switch over to the P next. That means C address. So P is switch over to C. It is sequentially processed. If the P is moved on to the D and it check whether the next is null means it just print the element in the D and it terminate the program. It is the process of how we traverse in the linked list. Insertion in a singly linked list. We are adding the node in the singly linked list. Yes, of course, we can add the list in beginning of the list, ending of the list and middle of the list. If we need to add any node in any time, you can easily add into the list. The insertion of the beginning of the list. If you need to add new node in the beginning of the list, of course, if we are having the list 20, 30, 40, A node, B node, C node, now the beginning of the list means we are going to insert the new node. It contains the number 10 before the head node because now the head node is the 20 element and now we are going to add the new node before the head node. So the coding is we need to get the element. First we create the node, new node. That new node must contain the next pointer as the null because we didn't create any link for that new node. So that new node contains the null as the next pointer and we need to get which element is to be inserted on that node. In our example, we are going to insert the 10 is our element means the node will be created as 10, the next pointer is null. And now we are going to we are going to do the link between this new node with the head node. So the coding is, so the node will be created using the malloc functions and the element is to be inserted on that node is to be getting from the user. That means that 10 element is 10. New is equal to data is equal to element. This step is used to, the 10 is to be the data, the element 10 is to be the data for the new node, so that the element is to be inserted on the new node. And now the new next is equal to head, which means the new node is to be created, that new node next pointer is points to the address of the head node. And now we will assign head is equal to new. Now the new node is to be the head node is to be the next node of the head node. So traverse, this method is already seen. It is used to whether the node is to be inserted or not. We can see in the list elements. The second one is the insertion of the node in the middle of the list. In the first one, we will insert the element in the beginning of the list and now we are going to insert the element in the mid of the list. So we need to create the node and of course we need to get the element which is to be stored on that node and which position you need to insert in the new node in the middle of the list. So we created the we get the position. Which position? For example, I am having the 3 nodes. If you are inserted your new node into before the third node means, so third position you need to assign. So you get the position. and you created the node and you get the element inserted into the node. So now I am using the pointer, using the for loop. Old is equal to P. So the old is, the P pointer is to be traversed in the first list to next list, and now T is equal to P of next. If the old of next is equal to new. So I get the position. On that position I am going to insert the new node. So that based on the position, the new node is to be inserted, and at the same time the new node pointer points to the third node address. So now the connection is automatically established. That means the new node next pointer is the already existed third node address. So the new node linked between the third node, and also we need to change the second node next pointer already having the already existed third node address. Now we need to change the second node address points to the newly added node address. So it is already existed address, so you no need to change that address. So we need to make the corrections, we need to make the changes in the new node next pointer. So old is equal to next is equal to new, the new next is equal to P, and we can traverse the list. Insertion of the node in the end of the list. So already seen the beginning of the list and mid of the list, and now we are going to add the node in the end of the list. In this we get the we want to create the node and as well as the next pointer. So the new node is to be added into the last node. So of course we already seen the new last node must contain the next pointer must be the null value. So in this no link exists between the last node and some other nodes. So we need to create the node, we get the element, and also the new node previous node address is to be changed, null value is to be changed into the new node address. In this program, so we are created a new node, that element is to be fetched, and new data is equal to element. That means which element, for example, in this exercise we are giving the 50 is the element, the new node created, the element is the 50, while P next not equal to null. So it is used to traverse the list if the while loop is find which node is having the null as the next node, it is the last node, and then the new node is to be added depends upon this last node next node. So P is equal to P of next. If the next not equal to null means P is equal to P of next. So P pointer is moved on to the first node to second node and second node to third node. If suppose P of next is equal to new node, P of next, N of next is equal to null. So the next pointer of the new node is to be set as the null. The new node is to be inserted in the P pointer. Thank you.